Good morning or good afternoon, gentlemen. Today we are looking at a couple more examples of our Appendix Section 1 notes. In class, only one class got up to me doing an example of a cube root. So we're going to do a couple examples of cube roots down here just so that we kind of have a little bit of a better idea of how to do those, so that when we have our homework due Monday or Tuesday, you can do those a little bit more effectively, and we'll give you a couple more problems here right now. Okay, all right, so scrolling down, I'm on the second page of that note document. We're going to look at these four. We'll probably do like this one and then this one, and then we'll call it a video from there. So it'll be a little bit of a shorter video. Okay, here we see our index is not 2, it is 3. Okay, just as we did before, I now want to look at splitting up my 72. So I picked two numbers that multiply to 7 and 2. Most people, or most classes, picked 36 and 2 when we saw this as a square root. Or recognize that this square root, like you would pick 36 because it's a square root and it would be able to come out. Not the case here because I have a cube root, and 36 cube rooted comes out as nothing, as a decimal. There is no number times itself 3 times that gives you 36. So I can't take out the 36 as a 6 here. Not a square, it's a cube. So what do? Well, just keep going. Split up my 36. We know it comes down to 6 and 6. Those are not prime. We get it down to 2 and 3 and 2 and 3. All of those numbers are prime. 2, 3, 2, 3, 2. All my numbers at the end of branches, they're all prime. Okay. My index is 3, which means that I'm looking for 3 numbers that are the same. So a 2, another 2, and another 2. All of those, there are 3 2's there. So my cube root would take that out. In essence, inside the 72 is a 2 times 2 times 2, which is an 8. So I could technically split up this 72 as 8 and 9. 8 times 9. The 8 would be cube rooted out as a 2, and then the 9 would stay in, right? So we see here, so here's my 2. I have 2 3's. Normally I would have been able to take them out, but because there's 2 of them, and I have an index of 3, I cannot take out my group of 2 3's. They have to stay in. I can't take them out. Okay? Now we do the same with the x's. 1, 2, 3, 4, 5. X, 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 X. Okay. As we know, I need 3 of them. Here's my group of 3. And just like with the 2 3's down here, I have to leave this pair of x's inside because I cannot take out pairs. I need to take out triples here because my index is 3. So my 2 x's stay inside. My 3 x's come out. And my final answer is 2x cube root of 9x squared, which is weird because 9x squared would normally be something we could take out of a square root, not a square root here. This is a cube root. Obviously, I would also include that 3 up there. Okay, and there's our final answer right here. 2x times the cube root of 9x squared. Right, so a little bit different getting used to, because you're used to seeing a 9 and x squared and all square things coming out. Not the case here. Let's look at the one down here, 108, because if you can do this one, the other 2 on the page are pretty easy. And I wanted to do that example with 72 because we saw 72 up above. Okay, 70, and this has 2 variables. Okay, so again, index of 3. I'm looking for 3 numbers when I'm looking for triples. 108, I don't know of any perfect square that comes out of 108 offhand, but I know that I can just take out of it a 2. 2 times, let's see, 54 would give me 108. Break up the 54 into 9 and 6. That's the first thing I see. The 9 comes out as a 3 and a 3. The 6 is a 3 and a 2. And those are all prime numbers there. Usually if it's an even number to start, which obviously a lot of times it is, I start by taking out a 2. 2 is a great prime number. It goes into every even number. And then I got something I can break up a little bit easier down here. Okay, again, I'm looking for triples. I got a nice group of 3 3s here. They come out as a single 3. I have 2 2s that I cannot take out because I have a cube root of 2 times 2. Looking at my variables, I have 4 x's here, and I have 3, 4, 5, 6 y's here. As I mentioned in class, to I think most of the classes, there is like a shortcut kind of, you can kind of do some of this in your head with the variables. It's pretty easy to write out all these arrows and circle, and you'll see that like on the homework, you have like a y to the 9th or something like that, and this can get very crowded. So there is a way to kind of do this shorthand, and let's see if you can figure it out. I won't tell you guys till next week, but see if we can figure it out. Anyway, I want my triples because 3 is my index. There's my 3 x's. They come out as an x. I have a single x left over with no 2 other partners, right? He needs 2 other people. Then with my y's, I need 3 of them. Here's 3 of them. Here's another 3 of them. So I get 2 groups of y's coming out, a y and a y. Inside, no y. No variable y because I took 2 groups of 3 out, so there's nothing on the inside. We write our final answer as 3xy squared. There's 2 of them. Cube root of 4x. And here is my answer right there. Right? And just to reiterate, I can write this as a fractional exponent. Here's my 108. It's inside of a cube root. The power of the 108 in here is a 1. My x to the 4th, x to the 4th, inside a radical with an index of 3. My y is to the 6th, inside a radical with an index of 3. And just as we saw in class, this 6 over 3, there's my squared. Right, so it seems to make some sense over there. Maybe you're starting to piece together why. What's my shortcut here? 4 over 3 for my x's, I get 1 of them coming out and 1 staying in, or an x, but to the first out, and then a leftover x in. Maybe we can start to piece together what that means next week, or maybe you can come up with it. Okay, good luck, gentlemen. Either today is Friday and you're waiting for the weekend, good old Halloween, and you're hoping that the Saint Cot apparel, new drip, comes out soon, supposed to drop pretty soon, or it's Monday and you just had a nice long extended hour of sleep for daylight savings time. So either way, it's a good day.